Okay, geometry, put on your thinking cap because I predict you're not going to like this one very much. Um, we're going to work on equations of circles, okay? And while none of it is terrible, it is going to involve a little bit of thinking here. Okay, let's pretend that we have a circle. And you know that a circle is defined as all the points that are equidistant from that center. So if I just pick a point here, um, you can use the distance formula or the Pythagorean theorem, really, I guess. So think about this. Maybe I should do it in different colors. Sorry. So this distance here is your x. This distance here is your y. Or maybe we should say a and b. So a squared plus b squared gives you the radius squared, right? So that's a very simple situation, but let's say that this is not at 0, 0. Like that's not at the origin. So this is just in space somewhere. And we'll say actually the center is at point HK. I don't know why they pick HK, but they do, okay? So now, using the distance formula, and I can't remember when even we learned this, chapter 2? Maybe chapter 3? I don't know, it was way back there. But you remember that the distance formula just said d equals x2 minus x1 squared plus y2 minus y1 squared, but the square root of that, right? Okay, let me stop there and just make sure you remember that. That's from way back when. That's the distance formula. Now, if we want to make this specific to this situation, instead of d, we're actually figuring out r, correct? And instead of x1 and y1, it was h and k. Oh, sorry, those are not, should be y2. Okay, so h and k. Let's get rid of that square root. We'll just square both sides. So that gets rid of this. And it gives us r squared. So right there, that is the equation for a circle. And that's the equation for a circle in standard form, okay? That's on the very middle of page 696, and this is pretty important. So if you're going to do anything with circles, you got to know this formula. So this would be something you'd write down in your note card or put it in the old noggin. So this is going to tell you the x coordinate of the center of the circle. This is going to tell you the y coordinate of the center of the circle. And then, of course, this is the radius. Okay. If we are going to graph circles, we're going to need to put things in this standard form. So let's run through an example. They give you, I'll just kind of work through example 3 with you, okay? They say the equation of a circle is x squared plus y squared minus 8x plus 2y equals -8. So first of all, you got to ask yourself, is that in standard form? And the answer is no, it's not. So we need to put it in that form that we just had there that I already erased. If you remember, it's r squared equals x minus h squared plus y minus k squared. That's what we're looking for. So we need to make this match up with that somehow. And the way that we're going to have to do that is your old friend from algebra, completing the square. So let's manipulate this a little bit. You can handle this. Let's kind of put the x's together. So x squared minus 8x. And then we'll group the y's together. Y squared plus 2y. And then we'll leave that over on that side. So just thinking about this, if we want to complete the square there, and we're completing the square, remember, so we can factor this, we take half of this and then we square it, and we add that to both sides. So half of negative 8, negative 4, add 16 to both sides. So add 16 here. And now we're going to rewrite this as x squared minus 8x plus 16. We're going to do the same thing with this guy. Half of that, square it, we're going to add 1, and we're going to add 1. So we're going to end up with y squared plus 2y plus 1 equals negative 8 plus 16 is 8. 8 plus 1 is 9. Okay, are we good so far? You can pause if you need to kind of work through it. Now we're just going to simply factor this. And the reason why we did this whole rigmarole with taking half of that and squaring it is because this now turns out to be a perfect square. It's going to be x minus 4, right? And the reason why we did this is so it turns out to be a perfect square. It's going to be y plus 1. We don't want this to be plus. We want it to be written in this form. So let's just do y minus negative 1. And similarly, we can write the 9 here as 3 squared. Now do you see this matches up with standard form, which is what we were looking for. So if we're going to graph this, we need to find where the center of the circle is. And it's going to be negative 4 and negative 1. That's the center of your circle. And we know the radius is going to be a radius of 3. So you could just go to that point on the graph. 1, 2, 3, 4. Down 1. Put a dot there. And then go out 3 in all directions and go around it. And you get a lovely circle like I just did. All right. That is pretty much it. They do tell you one more thing. They tell you that circles can intersect lines, which you already know. And, whoops. So you got a circle and you've got a line. At most, this can intersect in 2 places. But by using the equation, you know the equation for a line is y equals mx plus b. And you know now the equation for a circle. And by manipulating those, you can figure out where these are going to be. You can graph it and you can estimate it, but you can also do like substitution and things like that. And they do a great example for you on example 5. I think you can just follow that along, okay? All right, I'm sure we'll be talking about this in class tomorrow. All right, see you tomorrow.